Hello everyone, welcome back to A4 Analysis. In our last episode of Study Statistics with me, we discussed about estimating population parameters using sample statistics. In this episode, we will solve few of the mathematical examples or exercises from the book Business Statistics by Ken Black. Now, I have tried to take a few different examples for a few different use cases so that we can cover all types of problems from the exercise. So let's first take the first example, or the first problem statement I took was for estimating population mean when population standard deviation is known. So the first question is as follows. Use the following information to construct the confidence intervals specified to estimate mu. Mu is our population mean. So the first one has 95% confidence for x bar equals to 25, sigma, which is population standard deviation, equals to 3.5, and n equals to 60. So n equals to 60 means it's the sample size. Now for this, the formula would look something like this. Now we want to build or we want to construct the confidence interval. For confidence interval, the formula looks something like this. The lower limit will be x bar minus z into sigma by root over n, and the upper limit will be x bar plus z into sigma by root over n. So we are just putting the values from here. Only thing which we are missing is z value. So we already discussed about how to find z score from the z table. You can check out my video. It's also available in the same playlist. And once you have imputed the z value and all the other values are already available to us, we can find the confidence interval for population mean. Now the second one I tried was for 80% confidence interval, and x bar is equals to 56.7, sigma is 12.1, capital N equal to 500 and small n equals to 47. Now this D is looking a little bit different from all the other ones. That's why I did D as well. So for this one, our formula will look a little bit different. Here we have to use the correction factor, because when we are using the correction factor, it has this extra factor multiplied along with the old one. So the new formula looks something like this, or which is a more accurate formula actually. Sometimes we don't have the capital N or the population size available to us. So in such cases, we will go with the regular formula. But if we have, in case we have capital N value available with us, we can indeed use this. So using the correction factor, the formula will look something like this, where the lower limit of mu is x bar minus z into sigma by root over n into root over capital N minus small n divided by capital N minus 1. And the upper limit will be same thing, only in place of minus in the first element we have to use plus. So x bar plus the second element is exactly the same. Now we are just imputing all these values, and as you can see, we have taken this value of C as 1.282. Now one thing to remember here is sometimes Z value, the Z table is not available or not given. It can be the case when a very popular or the commonly used confidence intervals are given to you. In such cases, it's a good idea to remember the Z scores at least for 90%, 95%, 98, 99%. These are the commonly used confidence intervals. So it's better to remember at least Z scores for those interval levels. And if you have something uncommon, then of course you can make use of the Z table. Moving on to the next problem. So here I have taken one problem statement where there is a elaborated problem statement. Sometimes it's difficult to understand which is what because it's not directly written what is small n, what is capital N, what is our standard deviation. So sometimes we can get this kind of problem statements as well. Let's jump into it. So a candy company fills a 20-ounce package of Halloween candy with individually wrapped pieces of candy. The number of pieces of candy per package varies because the package is sold by weight. The company wants to estimate the number of pieces per package. Inspectors randomly sample 120 packages of this candy and count the number of pieces in each package. They find that the sample mean number of pieces is 18.72. Assuming a population standard deviation of 0.8735, what is the point estimate of the number of pieces per package? Construct a 99% confidence interval to estimate mean number of pieces per package for the population. Now let's first extract the numbers that we need. So first we have this 20-ounce package, which is none of our use. Next we have this 120 packages. This is actually the sample size or small n. Randomly sample 120 packages. So we have taken small n equals to 120. And next we have the number of pieces are counted, and we see that the sample mean is 18.72, which is plain and simple. So x bar will be 18.72, and standard deviation is also written explicitly. So we can just take it as sigma equals to 0.8735. Now what else do we need? We also have the confidence interval 99%. So now just we have to put this formula of the confidence interval, and we can just impute all the values in, and we will get the confidence interval. So here we have, we also need to find the point estimate. Point estimate is nothing but x bar. So when we are trying to estimate population mean, the point estimate will be the sample mean. So here in this problem statement, the point estimate is nothing but x bar, and it will vary from case to case. Moving on to the next problem in our hand. Again, this is a slightly different problem this time around. So a meat processing company in the Midwest produces and markets a package of 8 small sausage sandwiches. The product is nationally distributed, and the company is interested in knowing the average retail price charged for this item in stores across the country. The company cannot justify a national census to generate this information. Based on the company information systems list of all retailers who carry the product, a researcher for the company contacts 36 of these retailers and ascertains the selling prices for the product. Use the following price data and a population standard deviation of 0.113 to determine a point estimate for national retail price of the product. Construct a 90% confidence interval to estimate the price. Now, slightly different problem statement where we have a bunch of numbers given. What do we do with these things? So first of all, if you don't know how to calculate the standard deviation from a given list of numbers, please let me know in the comments. I can make one video for that. But for now, I will just quickly discuss how I have done this. So all these are the values for the sample data. So if I take just the average of these values, these 36 values, I will get 2.1386. I think there are few more decimal points and I haven't taken them. So this will be my x bar, which is our sample mean. Next, z value we can find really easily because it's 90% confidence interval. We already know this value. And after that, we have the sigma as well. So standard deviation is mentioned here. We got this already. Small n is 36 because it's already told as 36 of these retailers. And finally, we just have to put all the numbers into the same confidence interval formula and we are good to go. So this is the confidence interval we can find. And they have also asked for point estimate, which will be nothing but our x bar, because we are still trying to estimate the population mean. So for when we're trying to estimate population mean, we will be using point estimate as sample mean. So here also x bar is our sample point estimate, and the value is 2.1386 approximately. So that's it for the video, guys. Hope you guys found this video useful. If you found this useful in any way, please like, subscribe and share this with your friends, and we will meet again very soon. Bye guys.